Welcome back for another deep dive. This time we're tackling something pretty fundamental in the Java world, Spring Boot JPA.
Yeah, it's one of those topics that can seem a bit intimidating at first, but it's super powerful and honestly, once you get the hang of it, pretty elegant.
And whether you're a seasoned developer or just starting out with data-driven applications, Spring Boot JPA can be a game changer.
Totally. It really streamlines a lot of the headaches that come with database interactions.
So to kick things off, let's break it down for anyone who might be new to this. What exactly is JPA?
Okay, so JPA stands for Java Persistence API.
Okay, but what does that actually mean in practice?
Think of it as a bridge between your Java code and your relational databases.
A bridge. Okay, so it helps them talk to each other.
Exactly, and it lets you work with data in an object-oriented way.
So instead of wrestling with those clunky SQL queries all the time.
Precisely. You manipulate data using objects, which is much more aligned with how we think in Java.
That sounds like a huge productivity boost.
Oh, absolutely. It reduces a lot of boilerplate code and simplifies a lot of the complexities.
So if I'm understanding this correctly, JPA is all about making database interactions more intuitive and efficient for Java developers.
You got it. It's about bringing the power of object-oriented programming to the world of data persistence.
Now, I know we're focusing on Spring Boot JPA. So what makes Spring Boot so special in this context? Why not just use plain JPA?
Well, Spring Boot brings a lot of goodies to the table. For starters, it takes care of a lot of the configuration for you.
Oh, configuration. The bane of every developer's existence.
Right. Spring Boot is all about convention over configuration. It automatically detects your database, sets up connection pools, and configures the entity manager, all that behind-the-scenes stuff.
Less time fiddling with settings and more time actually writing application logic then? I like the sound of that.
Exactly. It lets you focus on the fun stuff. And beyond that, Spring Boot integrates beautifully with a whole ecosystem of other tools that work seamlessly with JPA.
Like Spring Data JPA, which I know we'll be talking about a bit later.
Yep. And a bunch of others. It's like having a whole toolkit specifically designed to make working with data a breeze.
I'm starting to see why Spring Boot JPA is so popular. It takes a powerful concept like JPA and makes it even more accessible and developer-friendly.
It's really about making Java persistence as smooth and intuitive as possible.
Now that we have a better sense of the big picture, let's start unpacking some of the key concepts.
Yeah, let's dive into the nuts and bolts.
One term I hear a lot in the JPA world is object relational mapping. What exactly does that mean, and why is it such a big deal?
Oh, okay. Object relational mapping, or ORM, is basically the magic that allows you to map your Java objects directly to tables in your database.
So I can think about my data in terms of objects, but behind the scenes, it's actually stored in those relational database tables.
Exactly. JPA handles all the complex mapping and translation between those two worlds for you.
So if I change an attribute of a Java object, those changes are automatically reflected in the database.
Yep, that's the beauty of it. And this has some pretty significant implications beyond just convenience.
Like what?
Well, think about code maintainability, for one. Instead of scattering SQL queries all over your code, you have this centralized, object-oriented representation of your data model.
So it helps keep things organized and easier to understand.
Totally. It makes your code cleaner, easier to debug, and less prone to errors.
That makes a lot of sense. Now, what about security? I imagine using ORM can help with that too, right?
You're on the right track. One of the big risks with traditional SQL is the potential for SQL injection vulnerabilities.
Where malicious code can sneak into your database queries.
Exactly. But with JPA, you're typically working with parameterized queries, which greatly reduce that risk. JPA handles all the escaping of special characters and makes sure that user input doesn't accidentally mess with your database structure.
So it's like having this extra layer of protection around your database interactions.
Yeah, you could think of it that way. It's one of the many benefits of using a framework like JPA.
Now, I've also heard the name Hibernate mentioned a lot in relation to JPA. What's the connection there?
So Hibernate is one of the most popular and widely used implementations of JPA.
So it's like the engine under the hood that's actually doing all the heavy lifting.
Precisely. It does all the work of translating your Java objects to database tables and vice versa.
So when we're talking about Spring Boot JPA, are we essentially using Hibernate behind the scenes?
You got it. Spring Boot JPA provides a higher level abstraction on top of Hibernate, making it even easier to use within the Spring ecosystem.
Okay, that makes sense. Spring Boot takes an already powerful tool like Hibernate and makes it even more streamlined and integrated with the rest of the Spring world.
It's all about synergy, right? bringing together the best tools and making them work together seamlessly.
And that's definitely a theme we see throughout the Spring ecosystem, making complex things simpler and more manageable for developers.
Absolutely, and that's what makes it such a joy to work with.
So now that we have a decent grasp of the overall picture, let's zoom in a bit on some of the key concepts you need to know when working with Spring Boot JPA.
Sounds good. Where should we start?
Well, we've mentioned entities a few times already. Can you give us a quick rundown on what those are and how they work in the JPA world?
Sure. In essence, an entity is just a plain old Java object, a POJO, but it's mapped to a database table. You mark these classes with the @entity annotation, and each instance of that entity represents a row in the corresponding table in your database.
Okay, so if I had a user entity, for example, each instance of that entity would be a specific user in my database.
Exactly. And within that user entity, you'd have attributes like name, email, and password. These map to the columns in your users table.
And JPA needs some way to know which attribute corresponds to which column, right?
That's where JPA annotations come into play. You use the @id annotation to mark the primary key, and you can use @column to customize the mapping further if needed.
So those annotations are like instructions for JPA, telling it how to map the Java object to the database schema.
Exactly. And there's a whole bunch of other handy annotations for defining relationships between entities, specifying fetching strategies, and really fine-tuning the mapping based on your needs.
It seems like annotations are at the heart of how JPA operates.
Oh, for sure. They're the glue that holds everything together and provides this declarative way to configure how your objects are persisted.
This is all starting to click now. But there's one more concept that's been floating around that I'm really curious about.
Shoot, which one?
Repositories. You mentioned them earlier, and I have to admit, I'm a bit intrigued.
Ah, yes, repositories. These are one of the most powerful features of Spring Data JPA. They basically give you this really simplified and elegant way to interact with your database.
Okay, you've definitely piqued my interest. How do they actually work?
Well, imagine you have a user repository interface.
Right, like an interface that defines how we'll interact with our user objects in the database.
Exactly. And this interface extends the JPA repository interface provided by Spring Data JPA. This base interface already comes with a bunch of predefined methods for common database operations like saving, finding, and deleting entities.
So I wouldn't have to write all those basic CRUD operations myself.
Nope. Spring Data JPA handles all that for you. It's pretty clever. It analyzes the method names in your repository interface and automatically generates the necessary queries to interact with the database.
Wait, hold on. It generates queries based on the method name.
That's pretty amazing, right? It's all about convention over configuration.
Okay, but what if I need to do something more specific? Like, what if I need to find all users with a particular email address?
Well, that's where the magic of query derivation comes in. You can actually define custom methods in your repository interface, and Spring Data JPA will figure out the corresponding query based on the method name.
So if I named a method find by email, for example, Spring Data JPA would know to look for users with a matching email.
Precisely. You define the intent with a clear method name, and Spring Data JPA takes care of the implementation.
This is starting to make a lot of sense, but I have to admit, it feels like Spring Boot JPA is doing a lot of heavy lifting behind the scenes.
It definitely is. It streamlines the development process so you can focus on the core logic of your application rather than getting bogged down in the nitty-gritty details of database interaction.
Well, I'm definitely appreciating that. And I'm really starting to see how all these pieces, entities, repositories, and all these clever Spring features come together to create this powerful and efficient way to work with data in Java.
It's a powerful ecosystem, and once you start working with it, you wonder how you ever lived without it.
Now, before we move on, I think it's time to address the elephant in the room,
Uh-oh, what's that?
the entity manager. It's a term that gets thrown around a lot in JPA discussions, but I have to admit, it sounds a bit intimidating.
I get that. It's a core concept in JPA, but it can seem a bit mysterious at first.
All right, well, let's demystify it then. What exactly is the entity manager and what role does it play in the grand scheme of things?
So, at its core, the entity manager is responsible for managing the persistence context.
Persistence context. Okay, more jargon.
Think of it as this intermediary space between your application and the database.
A sort of holding area for your data.
Yeah, that's a good way to think about it. It's where the entity manager keeps track of all the entities that are currently being worked with and handles all the low-level details of persisting, retrieving, updating, and removing those entities from the database.
So it's like the conductor of the JPA orchestra, making sure everything stays in sync.
I like that analogy. It orchestrates the entire life cycle of your entities and ensures that all those interactions with the database are consistent and, importantly, transactional.
Transactional. Okay, now that's a whole other can of worms.
Well, transactions are essential for maintaining the integrity of your data. They ensure that a bunch of database operations are treated as a single unit of work. Either all the operations succeed or none of them do. This prevents your database from ending up in a messy, inconsistent state if something goes wrong.
So if I'm transferring money between two bank accounts, a transaction would make sure that either both the debit and credit happen successfully, or neither of them does, so I don't end up losing money in the process.
Exactly. And the great thing about Spring Boot JPA is that transaction management is super easy. You simply annotate your service methods with @transactional, and Spring handles all those tricky transaction boundaries for you.
That's a huge relief. I've heard horror stories about managing transactions manually.
Yeah, it can definitely get hairy. But Spring Boot JPA takes care of all that complexity behind the scenes.
I'm really starting to appreciate how much Spring Boot simplifies these often complex aspects of data management. It's like they've thought of everything to make our lives easier.
It's all about developer productivity,
Right.
letting us focus on solving business problems rather than wrestling with infrastructure.
So we've covered entities, repositories, the entity manager, and even touched on transactions. Is there anything else we need to know before we jump into a real-world example?
There's one more piece of the puzzle that's worth mentioning, JPQL. It stands for Java Persistence Query Language.
JPQL. Okay, I have a feeling this is where things are going to get a little bit technical.
Don't worry, it's not as scary as it sounds. JPQL is basically an object-oriented way to write queries for your JPA entities. It looks a lot like SQL, but instead of operating on database tables and columns, it works directly with your entity classes and attributes.
So it's like an abstraction layer on top of SQL that lets you think about your queries in a more object-oriented way.
Exactly. And one of the cool things about JPQL is that it's portable. You can write queries that work across different database platforms without having to worry about the specific SQL dialect for each one.
That's pretty powerful. So if I need to write a complex query that goes beyond what Spring Data JPA can automatically derive from method names, I can use JPQL to get the job done.
Precisely. It gives you a lot of flexibility and control when you need it.
This has been an incredible journey so far. We've gone from the basics of JPA all the way to JPQL and transactions, and I feel like I have a much better grasp of how this whole ecosystem works.
We've laid a solid foundation. Now it's time to see how all these pieces come together in a real-world application.
Absolutely. I think our listeners are ready to see Spring Boot JPA in action.
Then let's do it.
Okay, so for our real-world example, let's build something everyone can relate to. A to-do list application.
A classic choice, and a perfect way to see how Spring Boot JPA can simplify data management in a practical application.
All right, so where do we even begin? We've got all these concepts, entities, repositories, JPQL. How do we actually, apply these to build a to-do list?
Let's break it down step by step. First, we need to define the core component, the task entity. This will represent each individual to-do item.
Right, so we're essentially telling JPA how a task should be represented in our database.
Exactly. We can define our task entity like this, and then there's some code here.
Okay, let's unpack this a little bit. So we've got the @entity annotation at the top. This tells Spring Boot that this class represents a table in our database.
Right. And then we have the id, the description, and a completed attribute. These will correspond to columns in our tasks table.
And I'm guessing the @add annotation marks the id as the primary key, and @generated_value ensures that the database automatically generates unique IDs for each new task.
You got it. So each time a user adds a new to-do item, Spring Boot JPA will create a new row in the tasks table with a unique ID, the description, and a status to track if it's completed or not.
Makes sense. Now, how do we actually interact with this task entity and the data it represents?
That's where repositories come in. Remember, repositories are our data access layer.
Ah, right. Those interfaces that provide us with all those pre-built methods for common database operations. So we'd need a task repository, right?
Precisely. And by extending the JPA repository interface, we get a ton of functionality out of the box.
So things like saving a new task, finding a task by ID, deleting a task that's all handled for us automatically.
Exactly. Spring Data JPA takes care of that for us. And what's even cooler is that we can define custom methods in our task repository to handle more specific queries.
Wait, we can add our own methods to an interface. Doesn't that break, like, every rule of Java?
It might seem a bit strange, but Spring Data JPA uses this technique called query derivation. Basically, it implements those methods for us behind the scenes.
Okay, so how would we, like, define a method to find all the completed tasks?
Simple. We just add a method to our task repository interface.
So this find by completed method, it takes a Boolean to indicate whether we want completed tasks or not. But how does Spring Data JPA know what query to execute just from this?
Well, Spring Data JPA is pretty smart. It analyzes the method name and uses a set of conventions to figure out the corresponding JPQL query.
So it's like Spring Data JPA has this built-in translator that understands these naming conventions and converts them to actual queries.
That's a good way to think about it. It's a really powerful mechanism that saves us from writing tons of boilerplate query code.
This is all making a lot more sense.
Yeah.
We have our task entity and our task repository.
Yeah.
But how do these actually fit into the bigger picture of our to-do list application?
That's where the service layer comes in. We'd create a task service class that would use our task repository to interact with the database and contain all the business logic for managing our tasks.
So the service layer is kind of like the middleman between our controllers, which handle user requests, and the database itself.
Exactly. So for example, if a user wants to add a new task, the controller would call a method in our task service, which would then use the task repository to actually save the new task entity to the database.
Got it. And this separation of concerns makes our code more organized and easier to maintain.
For sure. It keeps things nice and tidy. The service layer handles the what of our application, while the repository deals with the how of interacting with the database.
Now, earlier, you mentioned that there could be some challenges when working with Spring Boot JPA, things like lazy loading and query optimization. Should we be worried about these in our simple to-do list application?
Those are definitely important considerations, especially as your application grows and you start dealing with more complex data relationships. But for a simple to-do list, they might not be a major concern.
Okay, well, let's talk about them anyway, just so our listeners are aware. Let's start with lazy loading. What is that exactly?
So by default, JPA uses a lazy loading strategy. This means it only fetches the data that's absolutely necessary at that moment.
So it's like ordering a pizza, but only getting the toppings first and then deciding later if you actually want the crust.
Yeah, something like that. In the context of our to-do list, let's say we added categories. With lazy loading, fetching a task wouldn't automatically fetch the associated category. We'd have to explicitly ask for it.
And I'm guessing that can lead to performance issues if you're not careful.
Yeah, if you're not aware of how lazy loading works, you can end up triggering lots of additional database queries. It's called the N+1 select problem.
N+1 select problem. That sounds ominous.
It's not ideal, but luckily, JPA gives you ways to control the fetching strategy. You can use the @fetch type annotation to say whether you want lazy or eager loading.
So eager loading would be like getting the whole pizza with all the toppings and crust right away.
Exactly. It can be more efficient, but it can also lead to fetching more data than you need, which can have its own performance drawbacks.
So it's a bit of a trade-off. You have to think carefully about the relationships in your data and choose the right strategy.
It's all about finding the right balance. And that's where understanding how JPA works under the hood can be really helpful.
Okay, and what about query optimization? Is that something we'd need to worry about with our to-do list app?
Query optimization is essential for pretty much any application that interacts with a database. But for a simple to-do list, it might not be a major concern.
But it becomes more important as your application grows and you have more data to deal with.
Exactly. Writing efficient queries becomes crucial when you're dealing with large data sets.
All right, so what are some key things to keep in mind when it comes to query optimization?
Well, one of the most important is understanding how indexes work. Indexes are like lookup tables for your database that help it find the data you're looking for much faster.
It's like having a well-organized filing cabinet
Yeah.
where you can quickly find the document you need instead of digging through a giant messy pile of papers.
Exactly. And then there are things like avoiding unnecessary joins, using projections to only fetch the data you actually need, and choosing the right data types for your columns.
Okay, that's starting to sound pretty technical. Are there any tools or anything that can help us identify performance bottlenecks in our queries?
Luckily, most database systems have these profiling tools that let you analyze how your queries are being executed. You can pinpoint areas for improvement, and within Spring Boot JPA, you can enable logging for your query so you can actually see what's being sent to the database.
So we've got some options for fine-tuning things and making sure our queries are running smoothly.
We've got a lot of control, which is great. The key is to be aware of these things and to monitor your queries as your application evolves.
This is really eye-opening. Spring Boot JPA, it's not just about simplifying data access. It's like a whole world of tools and techniques for building really robust, well-performing, data-driven applications.
It's an incredibly powerful and well thought out framework, and the more you learn about it, the more you'll appreciate its elegance and capabilities.
Before we wrap up this section, can we talk a bit more about transaction management? I remember you mentioned that earlier, and I'm curious to know how it plays into our to-do list app.
Sure, transaction management is all about ensuring data consistency and preventing your database from getting into a corrupted state.
Right, so if something goes wrong during a series of database operations, we want to make sure everything is either completed successfully or completely rolled back to the previous state.
Exactly. So in our to-do list app, imagine a user wants to mark multiple tasks as completed at once. We want to ensure that either all those tasks are marked as completed or none of them are.
So if there's a network error or something goes wrong, we wouldn't want to end up with some tasks marked as completed and others not.
Right. And that's exactly what transactions guarantee. They treat a group of database operations as a single unit of work. Either all the operations succeed or they all fail.
Okay, so how do we manage transactions in Spring Boot JPA?
Well, Spring Boot makes this incredibly simple. All you have to do is annotate your service methods with @transactional, and Spring handles everything else for you.
So if we had a method in our task service called mark tasks as completed that takes a list of task IDs, we'd just add the add transactional annotation to that method.
That's all it takes. Spring will automatically create a transaction when that method is called, ensuring that all those database operations are part of the same transaction.
So if any exception occurs, the entire transaction is rolled back and none of the tasks are marked as completed.
Precisely. That way, our data stays consistent and predictable.
This transaction management feature is a lifesaver. I can only imagine how much of a headache it would be to manage all of that manually.
Oh, it can get pretty complex. But Spring Boot JPA hides all that complexity, making it super easy for us.
So we've covered a lot of ground here. Entities, repositories, the entity manager, lazy loading, query optimization, and transactions. I'm feeling pretty good about my Spring Boot JPA knowledge now.
It's been a whirlwind tour, but I think we've hit all the key points.
Before we move on, is there anything else about Spring Boot JPA that you find particularly interesting or insightful? Anything that really stands out to you?
You know, for me, it's the balance it strikes between abstraction and control. On one hand, it hides away a lot of the database complexity so you can just focus on your application logic. But it also gives you a ton of flexibility when you need it. You can fine-tune mappings, write custom queries, even use native SQL if you have to. It's really the best of both worlds.
Yeah, it's like having a really powerful tool that's easy to use for everyday tasks, but then there's this like hidden compartment with all these advanced features for when you really need to get under the hood.
Exactly. It's a testament to how well designed the framework is and to the power of JPA itself.
Well, this has been an amazing conversation. I'm sure our listeners are ready to go build their own Spring Boot JPA apps now.
I hope so. They'll be surprised how much easier it can make their lives, I think.
So for those who are ready to take that plunge, what would you recommend as a first step? Should they just dive into a huge project, or is there a more like gradual approach?
I always recommend starting small, to get a feel for the basics. The to-do list we talked about is a great example. It covers the core concepts without getting too overwhelming.
So build a mini version of what we've been discussing here.
Exactly. Get your hands dirty, play around with the code, and see how everything fits together.
And what resources would you recommend for someone just starting out? Where should they go for help and guidance?
The Spring documentation is always a great place to start. It's really comprehensive and has tons of examples.
And don't forget the Spring Boot community online. There are so many forums and groups where you can connect with other developers, ask questions, and share your experiences.
Oh, absolutely. The community is super helpful and always willing to lend a hand.
Well, this has been an incredible deep dive into the world of Spring Boot JPA. I feel like we've only just scratched the surface, but it's given me, and I hope our listeners, a really solid foundation.
There's always more to learn, but this is a great starting point.
And for anyone listening, remember, the learning journey doesn't stop here. As you get more comfortable with Spring Boot JPA, there's a whole world of advanced features and techniques to explore. Performance tuning, caching, working with NoSQL databases, it's a constantly evolving field. So keep experimenting, keep pushing the boundaries of what's possible. And a huge thank you to our expert for guiding us through this deep dive. Your insights have been so valuable. It's been a pleasure.
My pleasure. I always love talking about Spring Boot JPA.
And to all our listeners, thanks for joining us on this journey. We hope you've learned something new and are inspired to take your Java development skills to the next level. Until next time, keep coding, keep exploring, and keep that thirst for knowledge alive.